A report on the topic is offered for your attention. Information System for Positioning and Orienting Antenna System. The authors, N.Kryva N.Gashchyn Hlado, Ternopil Ivan Pulij National Technical University. Nowadays, various navigation systems for stationary and mobile devices have been developed significantly, enabling the determination of an object's position, direction, and speed, as well as its displacement from the horizontal plane. An important task is to determine the true azimuth and elevation angle of the antenna system's axis. The conventional existing systems are generally based on the outdated methods using gyroscopes, stabilizing platforms, and single-axis inclinometers. More modern systems are equipped with electronic triaxial magnetometers and accelerometers, positioning systems like GPS, and are controlled via microcontrollers. The development of a structural functional scheme and algorithm for a modern positioning and aiming system applicable in antenna technology is an urgent issue. The creation of a computer-based microprocessor system that can operate in field conditions and provide the necessary accuracy in determining specified directions in space for an antenna system. The proposed system consists of the following main components: a rigid non-magnetic platform on which triaxial accelerometers and magnetometers are mounted and rigidly fixed, ensuring their spatial alignment, a GPS navigation system, a microcontroller for processing data from all systems, and an interface part. The structural diagram is shown in Figure 1. Figure 1. The structural diagram of the proposed system. Let us consider the mutual arrangement of the coordinate system of the displaced sensor and the stationary coordinate system where the horizontal plane XY is parallel to the Earth's surface. The x-axis is directed along the antenna axis as shown in Figure 2. It is known that the direction of Earth's gravitational acceleration is always downward and the direction of the Earth's magnetic field vector is directed to the north. The above-mentioned error can be compensated using magnetic declination tables in the microcontroller's memory or transmitted over the Internet. To align the displaced coordinate system with the stationary one, it is necessary to rotate the x1, y1, z1 coordinate system relative to each axis so that the gravitational acceleration vector, recorded in the moving coordinate system, collinearly aligned with the z-axis of the stationary coordinate system. From Figure 2, it is evident that the first rotation needs to be performed around the OX1 axis to align the projection of vector g with the z1 axis by an angle beta is. The second rotation needs to be performed in this plane around the y1 axis to align vector g with the z1 axis by an angle xz. The specified rotation angles are calculated using the formula, where the magnitude of vector g is calculated using the formula. To determine the components of the magnetic field vector in a stationary coordinate system, we will rotate this vector by the calculated angles using a matrix transformation of the form, where T2 and T1 are respectively rotation matrices by angles beta xz and beta yz. These rotation matrices take the following form. The column vector of the magnetic field components in the shifted coordinate system can be written as follows, where xm, ym, and zm are measured magnetic axial values. The vector column m are obtained as a result of matrix multiplication of vector m will have known components oriented in the stationary coordinate system. The azimuth angle of the antenna axis directed along the OX axis is determined by the formula. The elevation angle of the antenna axis direction is determined. A distinctive feature of the proposed antenna positioning system is the connection with an external computer or network database. This database, using known GPS coordinates, determines the shift of the magnetic field vector, which changes over time and is constantly updated in the corresponding databases. Therefore, the true azimuth is corrected accordingly. To improve measurement accuracy and result stability, the well-known digital noise filtering methods should be applied, such as averaging or using a specific window function, or more complex methods like the Kalman filter. The developed microprocessor computer system has demonstrated sufficient accuracy in measuring the position of the object and can be applied in field conditions both for orienting the support turning device of the antenna system and for other similar systems, such as spotlight lighting, mobile device direction control, recording the trajectory of object movement, and others. Thank you.